So we previously looked at a video of how SinGAN works, and in this video we're just going to run it in our notebook. So let's get started. So again, SinGAN trains off a single image, and then you can do a bunch of different things with it once you have that training set up. This is the SinGAN notebook. It's, I hope, fairly well documented, so there should be able to go through it and find a bunch of the examples you need and the variables you're going to pass in as arguments, those sort of things. One thing to note is that yesterday when I shared this video, or when I shared the repo or the notebook as a part of the previous video, there was an error where basically you have to use a specific version of PyTorch to get this to work. So I've now updated the notebook, so it shouldn't be a problem. If you're still running into issues, let me know. So first thing, we want to make sure that our runtime is set to GPU. We are going to use a GPU for this. Since I'm on Colab Pro, I'm also going to set high RAM just so maybe it'll give me a little bit of quicker output. Not really sure that's going to happen, but let's see. So first thing we're going to want to do is just clone our notebook and then install the requirements. I think the only thing that we needed was this version of PyTorch and this version of PyTorch Vision. There's a bunch of other requirements, but I think they already come pre-installed with Colab. So we're going to run this. This is going to take a little bit of a minute because installing these new versions of PyTorch and Torch Vision just take a while. So this is going to take a little bit of time. So while that happens, why don't we go over what we're going to cover in this video. So I think for this video, I'm just going to cover training your image, generating random samples, and then generating some animations. So in that case, like all we're going to do is we're going to train this. One thing to note is that there is a limit on sort of the size at which you can train these images. It's GPU dependent, so if you're on Colab Pro and you have a P100, I think you can get up to about 600 pixels by 600 pixels. If you're on a smaller GPU, it's going to be a little bit harder. Also, the length of time it takes is sort of like exponential. The larger the image, the longer it takes to train this thing. I'm going to train this at about 256. It'll take about an hour to train, so what I'll do is I'll stop the video and come back because no one wants to sit around here for an hour. But just be aware that training does take a little bit of time, even with a single image. Then we'll look at generating random samples. There's a bunch of different ways you can do this. I'll go through both those examples, but it is fairly well documented in here. And lastly, we'll look at generating an animation. Animations, in my experience, are a little iffy depending on the image you use. So they've cherry-picked a good example with that lightning example that's in their notebook and I think in the repo. I personally have found that it's so-so, but we'll take a look at it and we'll see how that goes. So let's see where we are with installing stuff here. So we're still going. Just wait a couple minutes. Actually, while we're doing this, I will let you know that I'm recording this video as a part of a class that's starting tomorrow, actually, that is all on ML Art collabs. So basically, we're going to do a whole class just around like Google Colab notebooks to generate ML art. This will be sort of similar to what we do with Runway, where Runway we sort of explored a bunch of different models. Similarly, we're just going to explore a bunch of different models using Colab notebooks. So if you haven't seen this, I have a repo set up that just has a list of a number of Colab notebooks, doing different things. So we'll sort of go through them. I'll be recording videos and demos of things. I think Leah will be as well. We'll go through a handful of these, and the whole class is meant to help you learn more about Colab and become more proficient in it. So those videos will be up in probably about a month or two once the class is over. But want to thank all the students that are signing up for the class. Signing up for my classes helps me pay to keep making these videos and that sort of thing. So I really appreciate folks who are signed up for memberships and taking my classes. All right, cool. It looks like we're finished over here. So we've now installed everything. If you'll see in here, there's a SinGAN folder. On the side here, in our folder or in our files viewport, you'll notice there's an input and then there's images. So I'm just going to use the images that are already inside of the repo. It comes with a couple standard default images. But if you want to work with a custom image, your job is to upload an image into this images folder. And then what you'll do when you're doing training is you'll pass in that input name. So it's important that the image is inside of the images folder, because if it's not going to find it. This particular notebook like sort of has a predetermined path for a lot of things. I'm going to use this Coliseum image. It's a little guy, so I'm going to work off this one. So again, I'm also going to set the max size. Max size determines how large the outputs are. I'm going to make this pretty small just because I don't want to train all day and then have to remember to come back and record this video. So I'm going to make it pretty small. I think, if I recall, this takes about an hour to train on. So I'll run this. We'll just run this command. And you'll see it gets set up, and it picks a, I think this random seed is just to help with some of the noise inputs that it uses. And then here's our network, and then it's starting to train. So it trains at this scale level. So the whole thing about SinGAN is that it trains at each scale, and as it grows, it's almost like a progressive growing of GANs type of deal, where as it grows, it learns more. So this will run on 2,000 iterations at every scale. I believe it's starting at like a 4x4 pixel patch, and then it gets up to the full size of your output. So the full size will be 256 in this case. And if I recall, it's been a little while since I did one of these trainings. I recall that it's not like exactly 256. It sometimes is like around that size. I think it's like some of the scaling math that it does. It never hits exactly the number you're looking for. So this is going to run for a little while. You'll see, I don't know how many steps, I don't know what the scale it's going to end up on. The scale is based on the max size. So this might hit a scale of 4 or 6 or 8, but you're seeing it's running through 2,000 iterations at each scale. So this is going to run for a little bit longer. I'll stop the video and come back when we're done finished training. So yeah, I'll see you in about an hour. Okay, so this just finished training. You'll see at the very end of your output here, it looks like it went to the 9th scale, and it just sort of finished. I think this took about an hour and a half, so again, for a small image, it still takes a while to train this. So let's look at generating some samples. So by default, when you run this, once it's finished training, it's going to output a number of random samples. And I'll output here, so your image was in input images, your output will be in output random samples, and then the name of your image file. When you click on this, you'll see it generates using start scale of 0. So we'll look at what happens when you use start scale of 2 or 3, but we can just double click on these and sort of look at what some of these images are. So I'll just open up a random assortment of these. So you'll see each of these changes its structure, but quite a lot oftentimes. So this is the start scale of 0, and 0 is going to have the most fluctuation because it's starting at that very first layer. In here is a line of code that allows you to change some of these arguments inputs. So see here, your input name still gets passed in. Your mode is random samples. This is important because this is just going to randomize the function. Start scale, which we'll look at, is here. So let's change this to 2, and then let's run this again. So if you set this to 0, you will likely get an error message. So if we run this and we set 0, you'll see that it says already exists, and that's because this folder is here. So if you want to produce more of these images, you'll want to zip or delete this folder and then run this again. I'm going to run this with a scale of 2, so you can look at the difference there. And if I refresh this folder, I should see start scale of 2. So let's open just 0 and 1 from here. So you'll see that there's some pretty drastic changes in these images. And if you open up start scale 2 and you go 0 and 1, you'll see these images look almost the exact same. And that's because, if I were to open this in Photoshop and look at the details very, very closely, I would see that there's very minor differences maybe in the architectural patterns or in the water itself. Really fine-tuned details, whereas at 0 you're going to get much bigger changes. And my guess is that if I set this to 1, I'll get something sort of in between. Yeah, so you'll see some really minor sort of changes in the structures. So in my experience, you really don't want to go any higher than 2 or 3. If you set this to 3, you'll get really, really fine-tuned details that you probably won't even notice at this resolution. So just be aware of that. Now there is a second mode here that is also helpful to use, and this is the random samples arbitrary sizes. This will basically stretch your image size or change your image proportions, which again, if we looked at those examples from last time, which showed sort of the face distorting, that was how they did some of the face distortion. So I'm just going to use the Colosseum image again because that's what I've trained on. And this time, you have to use start scale of 0. I believe that's a currently open issue. Maybe they've solved that recently, but I'm just going to set it to 0 because you're also going to get the most interesting examples there when you play with that. So what you do here is you pass in a different scale or height value. So scale H is going to be obviously how tall it is, and scale V is going to be scale H is going to be how long it is, and scale V is going to be how tall it is. So let's set this to 2. This is just going to be sort of double the width of the original image and keeping the same height. And so when I come back here and redo my folders, you'll see now there's a random samples arbitrary sizes image or folder here. So we'll just go ahead and open a couple of these again. So here you'll see now you have a much longer image, right? And again, the structure changes quite a lot between these. So this would be fun. You could basically do this to sort of create some really wild looking images if you wanted to. All right, let's look at how to generate animations. So again, this is sort of going to generate an animation for you, and that animation will sort of flicker or alter between these different noise values. So again, I probably recommend that, I believe that animation can take in let's take a look here. So animation takes in, looks like it doesn't take in a scale, like a start scale. So my guess is that it probably just defaults to 0. And then the number of frames is set to 100. So let's just run this and see what we get. So I believe this is using my fork of the repo. Yes, it's using mine, and mine defaults to output of a video. I believe the other version outputs to a GIF, which is just not really my style. And now I'm realizing that also this has to train again. So I'll see you in another hour and a half. But yeah, so this is sort of the problem with SinGAN, is that every one of these functions generally requires a new training, which can just be really, really annoying. And I'm already seeing that I should reset this to 256 because max size at 32 means it's going to be tiny, tiny. So let's actually stop this. And let's switch this to 256. So we'll have the same scale as the other image, but we'll need to retrain this. So I'm going to run this again. I'll see you in an hour and a half again, and then we'll look at how to do animations. All right, so it looks like this finished. I'm seeing some errors here at the end. I think this just has to do with the basically the size that it was trying to output to didn't really work. So it resized some things to make sure it fits sort of the 16 log block. Seems fine. So let's take a look at some of these videos. So the first thing I'm going to do is let's grab one of these here. And then we'll just paste this in, and I think it looks like our size is 192 by 256. So 256 by 192. So let's see what this is. Alright, so this is our video. This is using a start scale of 0. Beta, I believe, is how much it changes. So this is the 0.95. So let's do 80 and look at that and see how that changes it. So it looks like the beta value increases the amount of global change. And let's look at start scale of 2. So let's just we'll switch this right here to 2. We'll run it. And you'll see very, very small changes in sort of the more local structures. Cool, so that is animations. So there's a couple different inputs you can put in here. I'm going to leave this at 256 since that's what we already did. You can change these to a GIF, so if you want to output a video or a GIF, you can do that. And then you can also increase the number of frames. I believe it always operates at 10 frames per second, so if you wanted to make this like a little bit longer, you could. If you want to change the frames per second, I think you'd probably just have to download it and then like use FFmpeg or something to change the speed of the video. So I think that just about covers everything that I want to cover in this video. So we went over, how to do your training, how to generate images, and then how to do your animation training and how to output images from this as well. So that's about it for SinGAN. I might get around to recording another video on inpainting and some of the other tools that they have, but it'll probably take me a little bit while because this is really what I like to focus on. So if you have any other questions, feel free to drop me a note in Slack or on YouTube. Thanks.